So turn to our example here. We've got our numbers in the table. If the bakery sells cakes for $10 each, how many workers should they hire to maximize their profits? Okay, so I just told you this decision rule here. We would like to produce as long as price is greater than or equal to marginal cost, and that's going to get us to the highest profit point. So I look here at my table and I can see the first worker is producing cakes at a cost of $3. Yep, that's less than 10. $4 is less than 10. $6 is less than 10. But I don't want to hire the fourth worker. Why? Because the fourth worker produces cakes at a cost of $12. I can only sell those cakes for $10. That's not a good deal. So I'm going to stop producing right here with 3 workers and 45 cakes, because that is the last point where the price of cakes, $10, is higher than the cost of production. So the bakery will hire 3 workers and produce 45 cakes, because that's the last place where price is greater than or equal to marginal cost. The reason why this decision rule is so important, it helps us characterize firm behavior for any price. So one way to approach this first question, to say how many workers should the firm hire to maximize their profits, would be to calculate profit for all of these different points and then to pick the highest one. You could do that. And that would tell you, for a price of $10, what point would maximize profits. But by calculating marginal cost instead, this allows me to see how much the firm would produce for any price without any additional calculations. We are going to do those additional calculations for a price of $10 because I want to show you that this decision rule does get us to the point with the highest profits. So let's calculate total revenue and profit for each possible point of production here for a price of $10. Total revenue is just price times quantity. So if I make no cakes, I get no revenue. Okay, 20 cakes gives me $200 in revenue. It's $350, $450, $500, and $530. Okay, total revenue is just price times quantity. And then profit will be total revenue minus total cost. So I'll just subtract. I got negative 20, 120, 210, 250, 240, and 210. Okay. So now you can see, yes, if the price is $10, this is the point of production that gives us the highest level of profits. So normally in a problem, I would not have you calculate profit for all of these points. I'm doing that here to show you that this amazing decision rule, this works, okay? And we're going to use this to help us solve all of our problems. I will, though, if you look here in part B, I will ask you to calculate profit, but usually only at a single point. So that's just one calculation. So we've already done this. We know the answer is $250, but let's just go ahead and write that out as if you were doing a homework problem or an exam problem. So profit is total revenue minus total cost. My total revenue is price times quantity. that's going to equal, right, I have a price of $10 times I'm producing 45 units, and that gives me $450 in total revenue. Minus my total cost, I can just read off of my graph here, but that would be all of your fixed costs plus all of your variable costs. That's $200, and that's how I get a profit of $250.